about section 4.1. I assigned a whole bunch of stuff. Is there anything you guys want to talk about here? Yeah, Allie, sorry, Ariana.
Okay. So like, when you're doing like the ones from worksheet 2,
Yeah.
some of them like you add and some you subtract. Like, how do you know what to add and subtract?
Yeah, sure. Do you have one in particular you want to talk about?
No.
Okay. So it's the answer to your question is it depends on the picture that you've drawn. So let's say we do like number 5 for the sake of argument. Sound good? All right. So first thing I'm going to do is identify the quadrants where cosine is positive, because we have a positive here. So that's quadrants 1 and quadrant 4, right? And then between 11 pi and 12 pi, what quadrants are those? Well, 0 pi, 1 pi, 2 pi. So I'm seeing that the odd ones are on the left side and the even ones are on the right side. So 11 pi to 12 pi is happening right there. So that would be quadrants 3 and 4. So our answer is in quadrant 4. So it's going to be somewhere down there, right? So draw my initial side, and then we got a lot of spinning to do. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi to 12 pi. Okay with that? And we'll identify our angle phi here. So if I look at this, if I compare which one is bigger, I have theta or 12 pi. Which one is bigger? 12 pi, because theta doesn't get to 12 pi yet. So to get theta, should I be adding to 12 pi or subtracting? Subtracting, because theta is smaller than 12 pi. How much should I subtract? Phi.
Okay.
That's all I'm doing, is I'm just looking at the picture and going, which one's bigger? Theta or that x-axis side? And then I'm just going to add or subtract phi respectively.
Okay, thank you.
Does that feel good?
Yeah.
That's simple, right? Once you have the picture drawn correctly, like that's easy to do, you just have to think about it for a minute. You know what I mean? But the picture tells me all my information, right? I'm not doing any arithmetic to figure that out. I'm just looking at the picture and going, which one's bigger? Yes, sir.
What is phi again? How do you find it?
So phi is just going to be the inverse of what you're given, but with an absolute value around it.
Okay.
And then that just goes into your calculator. You want to make sure you're in what mode? Radian mode. The direction should remind you of that as well. Tessa. Sure. I got a pile here on my desk. Sure.
No.
She gave you the dud, Holden.
This one works.
I'm just kidding. In this course, if you need to use the unit circle to do something, you always get one. There's not the expectation you'll have that memorized. Will never be an expectation that you have it memorized. Unless you take AP Calc, and then they expect you to have it memorized. But that's a tomorrow problem. All right, hi. Others, anybody else want to talk about some stuff? Ariana, doing this, what's the one place that we have to be really careful? Is if the angles you're looking at are negative. So like, let's take a look at this one. So if I do the same thing, sine is negative in quadrants 3 and 4. Going negative, I'm going clockwise around. So this is negative pi over 2. That's negative pi. So that would be negative 3 pi over 2. So those are quadrants 2 and 3. So my answer lies in quadrant 3. So there's my angle theta. I make my angle phi always with the x-axis. Now I ask myself which is bigger, negative pi or theta? Theta, because it's less negative than negative pi. That's the only sneaky part, right? Is you just have to worry about the negative signs being opposite. So we'll just be adding. Morgs.
So if you're going that way, then is the one down here, right? Is that one negative pi over 2? And then the top one is negative 3 pi over 2, right?
Yeah.
Okay, so it's opposite?
You're encountering them in the opposite direction, yeah.
Okay, yeah.
Yep.
Okay.
Right? So you have to be careful about those negative angles because your intuition gets up being reversed. But if you just think about it for a minute, which one's smaller? Now when I do this on my calculator, on all these problems that we do, on all these problems that we do, these are all checkable, right? How do I check this on my calculator? I have to check two things. I want to make sure that when I do sine of that angle, I get the negative 0.56, which I do. And then I want to make sure that angle is in between, that it's bigger than negative 3 pi over 2. So negative 2.5 is definitely bigger than negative 4.7. And that it's smaller than negative 1 pi over 2. And if I meet both those criteria, I know I have the correct answer, and certainly negative 2.4 is smaller than negative 1.5. So I know I'm right. So again, even if you're oh shoot, maybe I should have subtracted instead of adding, just check it. If you get it wrong, it's okay. Probably that's the most common mistake I'd be making, is that I just added when I should have subtracted, or vice versa. Pierce.
I'm confused how you know that, for instance, sine of negative 0.56, how you know that negative 5.3?
So sine, this is equivalent to just saying sine theta equals negative 0.56, right? Sine on the unit circle is y. So I'm just looking at the place where the y coordinate is negative. So quadrants 3 and 4. Cool with that? Katie?
Where's the range of sine? Negative 5 over 2.
Quadrants 1 and 4. That's what you're asking, right? Jacob.
Quiz, are you going to expect us to draw the arrow? Or how many times does it goes around? This is not part of the answer.
Well, I mean, that's part of like showing your work. So if you want partial credit, if you get the wrong answer or something,
Okay.
like I would need to see some stuff like that to justify any kind of partial credit.
Okay.
But at the end of the day, this should be something that you can
Sure do.
kind of do minimally,
Yeah.
you know?
Okay.
But in the beginning, I think drawing the picture is enormously helpful.
Yeah. Okay.
You guys feel okay otherwise? All right. Well, let's do section 4.2 then, and then we'll stop and do this quiz and be done for today.
I didn't get much of this. First time I didn't get out of them, but I don't sometimes do that.
All right. I want to start here with a little bit of vocab. So we have two terms that we'll use in this section: angle of elevation, angle of depression. So this is, rather than defining these things, I'm just going to kind of draw a picture. So let's say that there's one person down on the ground, and there's another person that's like standing up at a higher location. So if I'm the person on the ground, if I'm looking straight ahead, like that's my line of sight, right? If I raise my eyes to look at the person up above, this would be the angle that's formed, right? If I take my line of sight and I look up, everybody agree with that? That's an angle of elevation. Everybody's cool with that? Now, if you're the person on the building here, your line of sight looking forward is that. If you then look down at the person on the ground, that angle is formed, right? My line of sight, I look down, it's that angle. That is an angle of depression. Everybody's cool? Now, what do you notice about my angle of elevation, the angle of depression I've drawn here? Why are they the same? They are alternate interior angles. Those two lines of sight are parallel, right? Or they're two, initial lines of sight are parallel and you're cut by a transversal. Remember geometry? At least you're like, I hear that name and that was something. So those two angles that we've drawn there, the AOD and the AOE, would be congruent. The number one mistake that students make when they draw their picture is they take their angle of depression and they put it there. That's wrong. Okay? This is me warning you. Number one mistake students make on these problems is they put their angle of depression where I put that green star, not the angle of depression. Okay? All right. let's do some examples now. Sound good to you guys? Good, you didn't have a choice. That's what we're doing. Quit complaining. This is good math we're doing here today. You know what's the best part of it? Is that there's like nothing new conceptual to it. It's basically just right triangle trig again. All right. Christy is looking up at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the Fisher Building? All right. Well, I'm going to draw a nice simplified picture. So I know that this is 200 feet. This side is the height. That's what I'm looking for. And my angle of elevation is what angle? No, but like the name of the angle. Where do I put it? SKX, right? Now there's one other thing that I can assume about the picture here that I haven't labeled. What else can I assume? Right angled. So as far as you're concerned, unless they tell you otherwise, buildings, perpendicular to ground. Flagpoles, perpendicular to ground. Trees, perpendicular to ground. Unless they tell you expressly that the thing isn't perpendicular to ground, assuming anything standing on the ground is perpendicular to the ground. Everybody cool with that? All right, how do I solve for h here? Great, yeah. So relative to the 66 degrees, I notice that I'm looking for opposite and I know adjacent, so tangent sounds like a winner there. Cool with that. To get h by itself, what I do? Multiply both sides by 200. When I go to type this into my calculator, what do I have to be careful about? Yeah, I got to make sure I'm in degree mode here because the angle is measured in degrees. It says right so in the problem. So I know that the last thing I was doing was doing things in radians, so probably I'm going to need to have to change it. So I get about 449.2 feet. No big deal, right? Oh, let's do another. Jane has climbed a tree and is looking down on her friend Mary. Jane has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? All right, we'll draw our picture. Here's Mary. Here's Jane up in that tree. So again, we'll call this X. Says Jane is 17 feet up there. We have an angle of depression of 49 degrees. Where's the 49 to go? Yeah, not in the triangle, right? Really, the 49 degrees is here. Or the person that said you could label it as angle M also be correct. If you tried putting it XJM, You are wrong. This is exactly the place where I warned you about just a couple minutes ago. I'm going to point it out again because it is the number one mistake students make on these kinds of problems. They just put their angle of depression in the wrong spot because they're not thinking about it. Everybody's cool? And what are we looking for? We're looking for that distance, right? How far is Mary standing from the base of the tree? So what do you want to use here? Tangent. Okay, what can I say? Tangent of 49 equals 17 over x. To solve this for x, what should I do first? Multiply both sides by x. Good. Get rid of that fraction for starters. Don't divide by 17. You'll probably end up trying to tell me 1 over x is equal to 49 divided by 17 and just say, like, that's my answer. Or just divide by 17 and forget about the 1 over. More likely even. Then we'll divide by tan 49. And then it's calculator time, right? So just as a little check here, as I'm doing this, 49 degrees is pretty close to 45, right? So the answer I'm looking for, I would expect to be pretty close to 17. If it's a 45, 45, 90 triangle, the leg length should be the same, right? Now, the 49 is opposite the 17, so the 17 should be bigger than whatever my answer is here, but not too bigger, which is exactly what we're seeing at 14.8. So I'm pretty happy that I have the right answer there. Just doing a little common sense check. Everybody cool with that? Again, do you need to do the common sense check? No, but like, you know, you probably can catch a mistake or two by just taking 30 seconds and going, does this make sense? Is the bigger side opposite the bigger angle? You know, like, how much bigger should this side be than the other one? Would I expect it a lot or a little? You know, it'll be okay just to take a couple of seconds to do that. Oftentimes it's worthwhile, particularly if you put the 49 in the wrong spot. You know, like, maybe you catch it, maybe you don't. All right, last example, and we're donezos in chapter or section 2. What? I know. Is that lovely? Claude and Simone are riding bicycles in Paris. How romantic. At one point, they look up and measure the angle of elevation to the Eiffel Tower to be 32 degrees. Okay, well, let's start drawing a picture, I suppose. When they pedal 100 meters closer to the tower, the angle of elevation is changed to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? What's wrong with this? Do I know a side and an angle in any right triangle? No, I do not. Right? If I call this piece X, what I have is I have one right triangle here. Don't know a side and angle. And I have a second right triangle here. Don't know both a side and an angle. Oh no, what should I do? Yeah, I have two variables. I have two triangles. The natural thing to do would create a system of two equations. So using the yellow triangle, I can say tan 32 is equal to opposite over adjacent. And then using the green triangle, I can say tan 37.5 is equal to opposite over adjacent. There's my system. Everybody feel okay with that? What are we solving for in this system? H. Now, we have a choice here. It appears to me that algebraically it'll be easier to find x first and then plug in to get h. It's an extra step of like computation, but I think it'll be worth it because the algebra to get x first will be kind of a hassle. But either is okay. What I would probably naturally want to do is to just get rid of the fraction. So I'd multiply both sides of the first equation by 100 plus x. And multiply both sides of the second equation by x. So that both of the two equations are equal to h. Since they're both equal to h, I can set them equal to one another. Everybody's cool with that? To solve this now for x, I have to get the x's on one side. I'm going to start by distributing the tan 32. I would then subtract x times tan 32 to both sides. That'll move the x's all onto one side. Take a look on that right-hand side now. What do you notice? Both have an x. That's a greatest common factor, right? So I can factor that x off. And then I can divide by tan 37.5 minus tan 32. Easy there. I have to get so angry. It's just math. At this point, it's calculator time. I'm going to strongly encourage you to use the fraction command on your calculator. If I do alpha y equals, that way I can type this in exactly like it looks like on my sheet of paper. To do it otherwise requires a lot of extra parentheses that we don't have to worry about if we use the fraction command. At alpha y equals option 1 is a life and time saver. So I get x is 438.6-ish. Is that my answer, though? Nope. What am I looking for? H. So I'm going to go ahead and take this answer and plug it back into one of my equations that has an h in it. I'm going to choose that one. Press. So I get 336.6. And that's my answer. What do you guys think? Not too bad, right? Got the coming up with, oh, I need a system to solve this is probably the hardest part. But when you see like two triangles nested inside of one another like that, that's often going to be the technique you need to use to solve something like that, is just create a system with the two triangles, one nested inside of the other. Not a big deal. At this point, we are done with section 2. So you guys should be able to do numbers 19 to 23 and worksheet 3. Okay. Everybody happy enough? All right. Quiz time. Get them ready.